Everyone, welcome back to the channel. I hope you all are doing well. Today we'll be tackling a challenging problem from Geeks for Geeks. It is categorized as a medium level problem. So let's dive into the problem statement. The problem name is minimal cost. So the problem says that there is an array ARR of heights of stone and geek is standing at the first stone, okay, and can jump to one of the following stone I plus 1 I plus 2 I plus k stone, where k is the maximum number of steps that can be jumped and cost will be hi minus hj is incurred, where j is the stone to land on. Find the minimum possible total cost incurred before the geek reaches the last stone. Okay, so let's talk about the test cases. First test case is input k is equals to 3 and my array is 10, 30, 40, 50, 20 and my output will be 30. Why 30? Because geek will follow the path. First geek is here 10, then it will jump to 30. So till now my cost is 10 abs of 10 minus 30, which means mod of 10 minus 30, which means 20, plus now 30 to this 20, which is jump of 3. So for this jump my cost will be 30 minus 20, 10. So total cost will be 20 plus 10 is equals to 30, which is the minimum cost. Okay, hope you have understood the problem statement. So let's talk about the time complexity. Time complexity will be big of n cross k and expected auxiliary space is big of n. Okay, so let's dive into the pen and paper where I will make you a clear understanding of this solution. So I am going to discuss about the first test case where input is k is equals to 3 and array is 10, 30, 40, 50 and 20. Okay, now output will be 30. Why 30? Because the problem already said that you are here and you have to reach here, and you have to reach here with minimal cost. Okay, the cost will be the minimum. So you can do what things? K is given as 3, you can jump one step and you are here, you can jump 2 step, you are here, you can jump 3 step, you are here, and maximum you can jump 3 steps. Okay, hope it is clear. And after jumping here, suppose I have jumped 1 step here, my till now my cost will be, which is 20. Why? I can absolute value. Why absolute value? Because this value can be greater or this value can be greater. Okay, I don't know which value is greater. I have to jump from one place to another place, but with the minimum cost. Okay, and my cost till now is 20. Hope it is clear. Now I can jump from 30 to 40 or 30 to 50 or 30 to this 20. Okay, and if you see, to reach the end I can direct jump 30 to 20, where my cost will be absolute of 30 minus 20, which is 10. So total cost here is my 30. And I will not make my video too much longer, so I am not considering any other case. You can try it by your own. You can, instead of 30, you can jump at first 10 to 40 and 40 to 50, 50 to 20. You can check these kind of cases where you will get you will not get the minimum, and the minimum answer will be the 30. So from this problem statement, you can clearly understand that this is something problem of choices. Okay, so why choices? Because you can choose one step jump, you can choose 2 step jump, you can choose 3 step jump. Okay, this will depend on k. Now my main problem is what data structure we should implement here. So as I have already said that if you see any problem of choices where you have to choose between these much of things, and you have some recursion diagram, recursive tree, you have to draw some recursive tree, then you can simply do dynamic programming, or before that you have to implement recursion problem. So I will solve it by using recursion and dynamic programming both, because to learn dynamic programming, recursion is very much important. Okay, so what are the choices in front of me? At first choice is I can jump to 30 from here. At first I am here. Okay, at first I can jump to 30, or I can jump to 40, or I can jump to 50. Okay, when I am 50, then I have only one choice, that I will jump to 20. One jump is allowed here, because if I make two jump, then I will be out of bound. Okay, so here is the funda of recursion. So what my recursion will do? My recursion will, every time, suppose I am jumping from here, I am jumped 10 to 30, and I have told the recursion that from rest of the array, please bring me the minimum cost. Okay, I will make you another clear understand, because you have to keep it in mind. I have already said in my previous video that recursion is a magic. Okay, why magic? Because you have to think about the initial process of recursion, how it will work, and rest of the part will work automatically. You don't have to worry about the rest of the part. You have to just initialize the recursion. Okay, and you have to trust on recursion. This is the main point of recursion. And if you try to every time draw the recursive tree, then it will be very much messy and time consuming. So you have to just think the first step. In my very first step, what my recursion is doing, you have to think about just for it. Suppose in this example 10, 30, 40, 50, 20. Okay, now see what will my recursion do. At first I am here, recursion will tell that at first you go to 30, then you go to 40, then you go to 50. And suppose at the very first level I am here, okay, after one jump I am here, okay, and I will, when I am here, I will again call the recursion and I will tell that from the rest of the array bring me the minimal cost. Okay, so till now, suppose till now my cost is 20, and what I will do, I will call the recursion and from the rest of the array, and which will bring me back the minimum cost to, suppose I am here, minimum cost to go till the end of my array from here. Okay, so basically I am doing recursion here, I am trusting on recursion here. Okay, so what I will do, I will directly jump to the code where from where I will compare and tell, by which you can clearly understand. My function is int minimal cost of int k is given in the function and vector of int array. Okay, so what I will return, I will return 0 comma k comma array. These parameters I have passed. Why these parameters I will tell. So first I will talk about how recursion will work, then I will talk about the base condition. Okay, so my recursion function will be like this: recursion int index int k vector int array. Okay, this is my recursion function. This is my base case. I have not written this at first. I will go to the main coding part. Okay, hypothesis. I am going to the, so I have to store the minimum now. So for that I can declare a variable which will store the maximum, and every time I will compare with that, by which I will get the minimum. Okay, it is obvious. So what I will take, I will take one variable as int min cost, which is int max. Okay, then what I will do, I will run a for loop, and what will my for loop will do. So I'm showing here for int j is equals to 1, j less than equals to k, j plus plus. Hope you have understood that why I am using for loop, because when I am here, suppose at first I am here 10, at first I am here, so for loop will increase one step when j is equals to 1, one step, j is equals to 2, j is equals to 3, till j less than equals to k, and it will each time it will check for which it is giving me the minimum cost. Okay, so for that what I will do, I will declare another variable which is minimum cost, absolute of array of index minus array of index plus j plus. Okay, why I have done, I hope you have already know that my at first I have declared here 0 index. Okay, it will store the index value. At first I am here, and from index my j value will run from j1 2 3. Okay, so I will do absolute difference of when my j is 1, array of index which is array of index is 10, and my j value is 1, so array of index minus 10 minus array of index plus j, array of index is 0, 0 plus j is 0 plus 1 is 30, so 30 minus 10 will 20, so 20 will be added. Okay, 20 plus I will call the recursion function, because I have already told, suppose I have increased one step, and after that I have told my recursion function that please bring me the minimum value from the rest of the code. Okay, I will add it to this cost. Okay, I will add it to this cost, and I will check if this is minimum, then I will store it as minimum, and from here, after calculating this much, I will go to here, after increasing my j value, and I will tell please bring me this part only, from this part please bring me the minimum cost. Okay, then I will again, and here 40 minus 10 30 plus, meaning recursion of 50 comma 20. Okay, from I will ask from the rest of this array that please bring me the minimum cost. Okay, so what I will do, I will call the recursion function, and for when my index will be where, index will be index plus j. Obvious, my index is when I have, suppose I have j equals to 1, so from here I have to, from here it is a new problem. Okay, from here I have called the recursion, where recursion will solve the rest of the problem. Index plus j comma k comma array. Now what I will do, I will simply in min cost I will do minimum of min cost comma jump cost. Now you think here is a catch. Suppose I am here, my index is here, and I am running the for loop from 1 to k, 1 to 3. Okay, j is running from 1 to 3. So after running 1, if I adding 2 here, then it will be out of bound. Okay, so what I will check here, I will check if before entering into this, if index plus j less than is equals less than array dot size, then I will do this. Okay, then I will solve this, and what I will return here, return, I have already said that mean cost I have to return. Okay, now coming to the base condition. Suppose I have completed the whole part. Okay, now I am here, which is jump cost equals to absolute of array of index. Suppose I have jumped 10, 20, 40, 50, 20. I have jumped 10 to 50, okay, and 15 to 20. And when I am trying to jump further, then this is out of bound. So what can be, what will be our base condition? When I am here, when my index is here only, okay, because if I check the j plus 1, like here, see this condition, if index plus j less than array of size, if it is greater, then it will break the for loop. Okay, then I have to check if my index is here or not. If I reached here, if I have reached here, then please stop my recursion and return 0, because from here nothing to be added. Okay, nothing to be added because no further jump is required. So what I will return, I will simply return 0 from the whole case plus what is our answer, answer plus 0. So I have to return 0. So what will be my base condition? If my index is equals to array dot size minus 1, then I will simply return 0. So this is my recursion solution. Okay, now see, to memorize this solution, what I have to do, I have simply changed 3 or 4 line. Okay, you have to, for implementing dynamic programming, you have to see one thing, how many variables are changing here. When you are calling recursion, how many variables are changing here. Here you can see their changeable variable is only 1. So I can make 1D DP. Okay, 1D array or 1D DP. Okay, so you have to keep it in mind forever. In recursion call, you have to check how many variables are changing, and according to that you have to make the DP. If it is one variable is changing, then you have to make 1D DP. If it is 2, then you have to make 2D DP. Okay, so I am declaring a global DP here, int DP, because if it is not global, then in the for each function I have to declare the DP also. Okay, so I am declaring DP here, and my constant said that 10 to the power 4, so I will 1 2 3 4. Okay, this will be my DP size. Okay, so for safe side I will do 5. Okay, now I have to initialize the DP with -1. So what I will do, I will do mem set of DP comma -1 size of DP. So my DP, all the values will be -1. Now I coming here, what I have to check, I have to check that if I have already solved for this index, then I will return it. Okay, so what I will check, if DP of index not equals to -1, then what I will return, DP of index. Okay, because my this index has been already solved. Okay, and the change where is needed is here, return. What I will return, return DP of index is equals to mean cost. Okay, why I have declared as DP of index equals to mean cost? Because before returning mean cost, I have to store it into the DP array. Suppose this is my DP array, and for every index I am storing the minimum cost. Okay, for every index I am storing the minimum cost. So when I am returning back in this index, so I will get to know that what will be my minimum cost. Okay, hope it is clear. So for this, what I will do, I will at first store the minimum cost into DP, and then I will return the minimum cost. Okay, so this is a memorized version of this code. I don't recommend this tabulation solution, because in most of the cases tabulation memorization gives you the correct answer. So simply go for recursion and then convert it into DP. No need to do tabulation unless you are supposed to given that you have to do it in big of one space. Okay, so what will be my time complexity here? My time complexity here will be big of n cross k. Okay, big of n cross k. In the worst case, my time complexity will be big of n cross k. My n is the size of my array and k will be my how much I can jump. Okay, big of n cross k will be my time complexity. And what will be my space complexity here? My space complexity will be big of n, because I have declared one DDP. Okay, for that my space complexity will be big of n. So I am going to the compiler where I will submit my code and hope it will work fine.
So here is the solution. I have already explained the solution, so I will try to submit it. Yes, it is working fine. You can see that I have tried all the possible solution, and first one was recursion, and it was giving me time complexity runtime error, so that was not working. And after that I have memorized the solution. So that's my solution. I will explain the time complexity, why it is big of n cross k. Because see, for every index you have to check k steps. Okay, for 10 I have to check k steps, for like 30, 40, 50, these k steps. For 10 k steps, for 30 k steps, for 40 k steps. And at the worst case, see here you are not doing k steps, but you have to think about the worst case here, because it is big O of means worst case, so you have to consider the worst case, and for each element you have to do recursion of k steps. Okay, so the time complexity will be big of n cross k, and the space complexity I have already told that I have using 1D array, so or 1D DP, so that's why my space complexity will become big of n. So that's my solution. Thank you everyone.